Hello and welcome. I'm Bill Wake. We're here working on an Elm interpreter written in Swift. We've made a lot of progress in terms of getting some of the pieces up, but we're working on the function calls right now, and that's kind of the heart of it since Elm's a functional programming language. So let's go ahead over and get to Xcode and get going. All right, so we left off last time. We created this thing called a named function call, and we parsed it. And then at the end of the day, we're doing some refactoring. We made the type argument optional on the float values, just sort of a default so the tests read a little more nicely. And I don't know if we started any on integer values, but we want to do the same thing for integer value. I've already run the tests, so everything was green. Double check that. Yeah. Okay, all green. So it's a good time for us to start refactoring. Let's see. I suppose if we just look for integer value, we'll probably find what we're looking for. Okay, so here's the class. We'll need that. Yeah, there's an init, and right now the type is required. So we would like to make it so the type is optional. And because of the way Elm defines its numbers, the right type is number. So almost always when you create an integer, you're creating something of type number. Elm has rules that we haven't explored yet for converting between numbers and floats or numbers and integers. The only place we see that right now is the conditional. So the if statement, if one argument's an int, if some function or some Boolean, then an int, else a float, the if statement forces the type up to float, so it makes it always a float. Other than that, I don't think we've done any kind of conversions or anything like that. But right now, I mean, this is one of those harmless changes. Yeah, I could even push this, I guess. Won't hurt. Make integer value except. Well, I was a little early there. Make integer value except a default type argument of number, or maybe make it use. Okay. I miss one of the things IntelliJ has is there's some plugins, and there's a nice one that's like limited whip and lets you set up kind of a TCR mode. Basically run the tests and push if they're green kind of thing, or revert if they're not. I missed that. I tried to set one up, but it was too clunky and slow, too annoying. So yeah, you live with the manual way. All right, now we got all these other ones, and really I want to focus on the tests. I don't care on, let's see, do we have any? I don't think I have anything else that's not a test, it looks like. Well, there must be something somewhere. Oh, there's tuple tests. Those are tests. Okay, what do we got here? To do parser. Oh, yeah, there's the parser. I'm going to leave the parser alone. There's one place to be explicit. I think that's probably the place. But the tests, we will go ahead and delete these extra arguments. Okay. Test if. Yeah, I think that's okay. All right. So here you can see our if statement. It takes two numbers and it tells you the type is number. Does that communicate? I think it's okay like this. All right. Here's the case I mentioned. If you pass an integer and a float, it bumps the type up to float, either branch. Let's see, it seems like I could probably search for comma elm type dot number. Okay. This one is the assertion, so we can't do that. really only after the ones inside integer values. That one's okay. All right. Oh, let's run tests. All right, and I'll just push parser test use default type for integer value. Seems good. All right, and we'll take a bigger step here maybe. Class integer value test. There we go. I didn't use Elm type.number there. Inconsistent. I'm not clear when it knows it can use that type. I mean, I guess the argument is an Elm type, so maybe it's willing to infer something. This one I'm not going to. Maybe I should not do it here either. Yeah, I'm gonna leave it more explicit on this test. Okay, EQ for different types returns false. That's probably okay. All right. So integer value tests usually use default value, default type for integer value. Okay, if expression, I think that's okay. Looks like we missed a float value here. And parent type, yep. Elm type.number. Definitions. Oh, symbol table. Okay. Here's lambda expressions. Don't know why it wouldn't stop there, but okay. Elm type function L type number. That one we gotta keep. This one's an integer value. That's an integer value. All right. This is the kind of thing it would have been good to do earlier. But here we are. Integer values. Okay. value 2. Okay. That one we can't do. That one we can't do. And that's another type. Okay. Do we have more? One more set. Okay. Integer value, integer value, integer value, integer value. Okay. And we'll run these. Make other have a remaining test use default value for integer values type. Okay. All right. Well, we picked something easy to start with. It's been a week here. All right. So today's the 9th. And I can't really call it a story, but I'm going to call it a refactoring. All right. Now I want to get back to these functions. Okay. Let's close some files. And I think between this and our parser, we should have what we need. Okay, so I guess, I'm just learning my way through this stuff. There's not sort of a definitive semantics for Elm that I've found. Someone does have a very large test case of all the syntactic elements, and we'll have to try that at some point. But what we've done so far is we've said, well, okay, so you have expression, and I guess we have expressions. That's the real thing here. So, all right, let's go back up to the top. So here's parse, and what parse is going to do is parse the incoming code, the string, and return an expression, a tree that represents the whole function, the whole bit of code. Now, if you see end of file, it's empty. We haven't really dealt with that. If you see lowercase name, you could be looking at a function call or a definition. If you see something that can start a regular expression token, then we'll also call expression call or definition. And otherwise, we say it's an error. Okay. And in here, function call or definition, you're only allowed one equal sign. So you can have a list of expressions. You could say function of A, B, C equals A plus B plus C. Okay. And that's fine. Or it could equal function 2 of A. That's fine, but you have one equal sign. So everything up till there, you read the expressions, and that's going to be it could be a series of it could be A plus B, except we don't handle plus yet. But in the long run, A plus B. It could be lambda n goes to n plus 2, so a lambda expression. It could be a variable. It could be what's one we know exists. I don't think we've used any. Let's see. There's certainly a sort somewhere. It could be sort of a list, and at any rate, it's going to be one or more expressions, which could be a function and its arguments, or it could be some other things, followed by an equal sign, followed by whatever the right-hand expression is, a definition. Actually, I think this is correct on the bottom. It's an expression, one expression. No, it's wrong. Expressions. Okay, we haven't really deeply tested that part yet. But in this thing, you either, if you have an equal sign, then it's going to be some sort of definition. If you don't, then it's just going to return this left-hand side. The naming is a little weird, but left-hand side, right-hand side, pretty common abbreviation in this sort of stuff. It just returns that list of expressions. Well, what are they? Well, you first start with the first one, and then you read the rest of them, okay? And at the end, we decide, are you a single expression? Then we're just going to return you directly, results of 0. If that was an error, then we're going to return the error. And then otherwise, we're going to make a named function call. The first argument is a variable, and then we'll take the rest of the things as the argument. Okay. Expression has all these possibilities. We're not going to go deeper right now. The thing that I noticed or realized over the weekend is that I've sort of assumed that the first argument is special, and then it's going to be a variable at this point. Okay. That's really not correct. Okay. It could be a lambda expression. We could say lambda n goes to n. Boring, but okay, it's a valid expression. Put that in parentheses and pass 3 to it, and it says return 3, and it's a valid function call. So I don't know. I don't want to work my. I'm realizing this thing named function call is not really correct. And somewhere else we had lambda function call. Where'd that get off to? Lambda. And it's got a lambda expression. Okay, so a definition, a lambda definition. I think this is more tangled than it needs to be. Okay, so I think what we're going to do is I want to make this. I guess I want to take the name out of it and just pass in the results. And you got a bunch of results. And you're gonna do something. What are you gonna do? Well, you're probably going to attempt to call result 0 or evaluate it. It may give you a function. It presumably will give you a function if there's more than one expression in the list. We'll apply that function to the arguments on the right hand side. But it doesn't have to be a variable. It could be a lambda expression. I'm sure there may be other possibilities even. Who knows? So I want to refactor this. We're not doing anything with it yet. So let's go back over here. We're making sure you can return its string value so we can debug with it or, test what we're doing, I guess. We'll never return that as the result of an evaluation because a function call with its arguments is not yet evaluated. All right, we look to how to make this thing test for equality. All right, so you're equal if your variables are equal and your list of values is equal. If your variable is the same but the values are different, you're different. If the variables are different but the values are the same, you're different. Yeah, I think that's pretty minimal. And let's get this thing up here. Named function call. Okay. And yeah, really, this thing is minimal too. It's just got an asString method, and it just gets the description for these things. Okay. Let's see. So what I want to happen is I want to take out this variable and put everything in the expressions list. Okay. So I don't know if there's a way to do this without breaking things. That'd be kind of nice too, wouldn't it? Well, let's see. What can I do to make things not break along the way? Could I do this? Let's see if that builds. And this is temporary. I should rename that. I'm going to rename it to TBD. Okay, good. All right, now what I can do is I can find every call site that creates a named function call, and I can pass in just the expressions. I don't know. This is a little bit squeaky or something, a little bit weird. Okay, but I'm saying I don't need this anymore. I can just pass result in. I don't need to drop the first anymore. Okay, so let's build. See if the build lets it go. No, it's not going to do that. Okay, let's try a different way. Okay, I'm going to take this out completely. Well, let's keep this part. Okay, so if you don't provide the variable, you get the first constructor, set the variable, set the expressions, and your type is unknown, which that's okay for now. All right, now if you do this, I think you're okay. Well, let's see. Let's build this. Now, I think our test should fail, and they should tell us what to do. It's my hope. Okay, 0. Built. All right, which test failed? Probably the last one's function call. Right, so if we call function 3, now we expect variable function and integer 3 all in the expression. Okay. Good. All right, now who's calling this? Callers. Okay, 2 tests. All right, so in this case, we're going to again pull variable function in. Okay, as string, that should still be okay. Oh, I should just run the one test. Oh well. So much for that theory. Okay. Oh, it should be in the brackets now. Let's try that. Well, what are we getting? Variable TBD expression. Yeah, that's true for the moment. Well, no, that's what we want to change. Okay, so let's go back to NamedFunctionCall. As string is not going to do the variable description. It's just going to do the expressions description. I mean, using this thing to kind of drive us to find the next problem is a little different, I will grant you. Okay, so I'm going to pull this in to the expressions. Okay, same thing here. And here. All right, all tests should pass. All right. This is good. Now nobody's using this. Callers empty. Okay, so we'll delete this. And who's referencing variable? Well, not much. Let's see. Definition. Well, okay, if we don't initialize it, let's take it out. All right, then we should have one more non-use of it. We don't longer have a variable, so it's just really comparing the expressions. All right, so you're equal if you're both function calls and your other one is equal. Now we may have a place. Let's see, what did we do? Make sure we did the parser right. Oh, yeah, we still just had that variable in result 0. That's fine. Okay. Yeah, so let's check this in. Whoops. Stop. Try again. All right, so we made named function call keep its first expression in the array with all the other expressions and dropped the variable, maybe separate variable. Okay. Now, I don't think this thing is a named function call. So well, we got to make sure we get things going in the right places. But let's say we have lambda, I'll just write it in here. If we have lambda in, put in parentheses, lambda n goes to n, well, we'll do n plus 1, even though we don't quite handle that, and 3, okay, then that's a perfectly valid function call where the first argument is the function, second argument is its argument, a second expression is its argument. And if we pass 3 to that function, then it should evaluate and return 4. Perfectly legitimate. Let's see if our grammar will get us down that path. All right, so the lowercase name function caller definition. Yeah, we can look at this thing. Okay, so which tokens can start an expression? Integers, floats, names, left parentheses, lambdas, or if. Okay, that's the expressions we know how to handle right now. Okay, so if you call parse with our expression, lambda n, whatever, it says, yeah, I see this parenthesis can start an expression called function caller definition. This thing doesn't see an equal, so it takes this left-hand side path, returns the list of all those functions, and expressions. Well, this may be, oh, it's expression plus, so you have to get 1, and after that you get all the others. Okay, and if there is just 1, you return it. If that 1, well, this doesn't really make any sense, does it? If the result count is 1, you return it. If the result count is greater than 1 and the first one's an error expression, then it's an error expression. Otherwise, it's a named result. I think we have some work to do here with the error handling. But now we have this named function call. And so it's going to parse, it'll parse the lambda n parenthesis, lambda n goes to n plus 1, and the 3, and return them in a list. And that's exactly what we'd like to see. What was going on funny down here that made me twitch a little? Lambda, no, returns a lambda expression. That's legit. Okay, so my oh no, there's something else going on. Where's that lambda? See, I think we made it harder. Lambda goes to expression. Try arrow goes to expression, return lambda expression. No, that seems okay. I was worried we had a different approach to evaluating, but I don't think we do. So this named function call, let's see. I had two things that said function call. That's why I'm getting, yeah, where's this thing coming from? Closure function call. Maybe we just put that in. You know, I think we were just doing a little bit of a spike on evaluating functions and put in closure function call. Let's go to its definition and find usages. Where is it created? Callers. Test, test, test. Yeah, that's just left over from there. Okay. Yeah, we're going to simplify things. Okay, so I think what we have here is not named function call, which was, you know, sign of X or something. This is just a function call. And I think this closure function call is just a function call. And maybe he sort of assumed a closure and then a one argument expression. Okay. Okay, I'm going to rename this one. At least lock in something. So this insight is there's no named function call versus closure function call. They're all function calls. You evaluate the first argument, you get either, well, hopefully you get a function if it's got more than one argument or more than one expression. If you don't get a function, it was just a simple expression. Otherwise, you get a function of some sort. Ultimately, it resolves to a lambda function, which is our closure case. All right, so let's rename this. Named function call is going to go to function call. Okay, now this thing, I believe the only place that cares right now is our one test. So we'll do it backwards. I don't know. It's not TDD, right? It's some other thing. But you know, it's taking advantage of the fact that we have we have this sort of double entry bookkeeping kind of idea that you know, things are defined in two places and they need to align. So we'll just do it this way. Right. Okay. And tests. Named function call tests. Let's check this one in first. Commit that. Well, okay. So we have our function call. That's good. Let's get our named function call tests. Rename this thing as well. To just function call tests. Okay, rename the file for us. Cool. All right. Rename named function call tests to function call tests. Nice, nice, nice. All right. I'll just run a test. I guess I should have done that before checking. Okay. Error checking. We haven't done that. There's no such thing as named function call at this point. How to handle multi-argument functions. Okay. And function definitions with arguments. Right now we can just let you define function equals lambda n goes to something. Okay. And we got some UI stuff hanging out there. Okay. So I guess this was all a big refactoring. We made named function call treat its first argument just like the others. And then rename named function call to just function call. Right. All right, now we mentioned error checking. How to handle multi-argument functions. Yeah, so the challenge here, so let's see if I can just write a test case. Let's say I have functions f and g. Okay, so if I say f of g of x, I'm pretty sure I want g of x to evaluate first. And I want f to take one argument. I don't know if that means, does he say, I take one argument, give me the next expression? I think that's what he does. Let's bring up the REPL. Okay, so we're going to say f equals lambda n goes to n plus 1. G equals lambda n goes to 3 times g. Oh, 3 times n. Okay, so we got f and g, both functions. If I say f of g of 2, we expect g to multiply by 3, so it should be 6, and then the f function was n plus 1, so I expect the result 7. Oh, interesting. F expects this, so we have to put the parentheses in even here. All right, so we're trying to get these intuitions about what Elm's going to do. So what it seems like it's doing is it's taking that first expression and it says that's a function. How many arguments does it have? Well, it can look that up because it's defined. And do you have that many arguments in your thing? No, you don't. Okay, let's try f of g of 2 plus, how about 1 plus 1? G is 3 times. What do we get there? G must be, it must have taken the g of 1, which is 3. 3 times 1 is 3, plus 1 is 4, plus 1 more for the f is 5. Not what I expected. So the precedence of function calls is higher than the precedence of plus. That's really interesting. Now, I don't know why it didn't. So basically it's interpreting this as this, g of 1 plus 1. I guess it's that. But if I take out the parentheses, it should complain that it has 2 arguments. No, it's okay. Tell me that's not weird. Okay. F of g of 2, it doesn't like it. I guess it's got another function and it knows it needs to evaluate it. We'll have to be careful around this. Okay, but I think we're ready to start trying to evaluate, and then once that's done, we'll merge the closure stuff back in. Okay, so let me add a task for that. Well, let's evaluate a function, merge closure function call to function call. And we got some error checking to do. Well, and maybe the error checking might be better to move up front, like that f of g of 2 thing. Okay. All right, and then we don't do pluses yet, so we can't quite create this case. Okay, let's try another function. Let's let j equals lambda n goes to, I don't know, lambda m goes to n minus m. Okay, so j of 3, 2 should be 1. Okay, and let's let k equals lambda x, I'll just use different names to keep things separated, goes to x times y. Okay, so if I say j of k of 3, 2, I think it should come back and say, you only gave me one value for j. No, it says j got 2, but it expected 2, but it got 3. K3, 2, 1. Okay. But if we parenthesize, it's fine. Okay. All right. So I think we're at a good point for a break. So we'll take just a couple minutes. And we're going to come back and start doing some error checking and evaluation. So I don't think we'll finish evaluation. Well, if we finish this, I'll be surprised in the next hour or so. But I think we'll make a good dent. Okay, we'll see you in 2 minutes. Welcome back. All right, so we're going to look at our parser and the tests we're doing around function calls. Okay, so I know we had a function call in there. Well, there's definition, function call. Okay, so we're just dealing with the parsing function calls this value 3. Okay, we haven't dealt with failed parses at all yet. Okay, so let's do that. So what can go wrong? All right, so let's say bad argument. Check failed parse. Our input is going to be function of 3, no closed parenthesis. And I would expect to get error messages dot missing right parenthesis. Okay. Now it may be that maybe there's some other error that can show up too, but I think from a parsing point of view, this is correct. Okay. Yeah, let's see what this thing does. I think it's just going to return the function with the thing in it and not call that. Okay. Missing a right parenthesis is not equal to function call variable function missing a right parenthesis. Yeah, so the error is present, but we don't detect it. And that's a direct consequence of the way we're doing expressions. So we read the first expression, we start in on the rest of the expressions, and at the end, if there's just one result, we return it. Okay. Now, in this case, if the first expression was bad, then yeah, we would return an error expression. But we don't do that. We just fall through and return function call result. Okay, now what I'd say should happen is if there's an expression inside, I would say like the first one should be returned as the result of the whole thing. We've got to bubble up something. I mean, if it was any of them, I wouldn't be too upset, but it definitely should be the first one. I mean, sorry, it definitely should return something, some error condition. All right, now this part is actually accurate. If there is only one expression, we don't bother. It's not a function call. It's just an expression to evaluate. This is not correct though. So I think what we're really trying to say, let me comment this briefly. Okay. Let's see. Let me take this case actually. If everything's okay, then it should just return the function call with the expressions in it. Maybe expressions would be a better name for that too. We'll come back to that. But in this case, I think the case is if, well, result dot, what's the opposite of all satisfy? Contains where? I'd really like to get that value. Let's look at arrays definition. Is find first, right? Isn't that it? Find first. Apparently not. Find contains where. Yeah, that's what we want. That's a Boolean. I would love to find the element. Yeah, first where. That's what I'm after. And it can be null. Okay, so that's cool. All right, so if result.first where, let's see, what do we give it? A function. We'll give it a lambda. So $0 excuse me, $0 equal is error expression okay, if let result equals that stuff, then we're going to return error. Sorry, excuse me again. All right, so if we find a result where there's an error expression, so if any of the elements, then we just return the error. Okay. Otherwise, we're going to return the function call. Now, this I think we could argue this could be just as clear here. Okay, so if anything has an error, return it. That catches the same case. If the count is 1. Well, actually, it catches a different case, doesn't it? Okay, maybe 2 steps. Well, if the count is 1, we return it. If it happens to be an error, then it's the error. So, I was... I'll convince myself both ways yet. All right, so if there is only one result and it's an error, then result.first is going to be that error, and we'll return that. Otherwise, we return result sub 0, because if there's only one expression, this thing's returning a simple expression, not a function call. Okay, like if we just evaluate 3, that has a result of 1, a result count of 1, and we just return the 3. And otherwise, we return the function call of the result. I'm content. All right, now I expect a passing test. We'll see. Yeah. Okay. So we're detecting the case where any argument, well, the function or any argument or a standalone value, if that has an error, then we catch it and return it. Otherwise, we return the proper kind of result. Cool. And I can't rename this to expressions because the function's called expressions. It's not even the result. Well, I'm going to say the expressions. I don't know. I mean, it really wasn't the result in any of these cases, so I can't call it result. I can't call it expressions because it's that. I don't have another name for the list of expressions, so I'm going to live with this. Okay, so this is function call. Any error bubbles up. Okay, that's cool. That was easier than I thought. All right, so we're still in function call. And error checking. Well, I'll be more specific. A syntax error in any expression bubbles up. Okay. So we haven't dealt with semantic errors, but that's fine. Okay. And I think we just have to do changed, right? Yeah. Okay. So where are we then? All right. Is this adequate? I think I'm okay for now. I mean, what other errors can you have in this thing? If it's malformed syntactically, we want to catch that. If it's just there as a name, I don't think we can get a syntax error from that. I don't even think we can get a semantic error just looking at the expressions directly. Let's go back to the REPL. I'm thinking of a case. So let's say function equals lambda n plus 1. Okay, so an increment function. So if you what can I make go wrong? Well, if you say function of 3, right, and function of 4, yeah, that's what I want to do. Okay, and function of 3, 4. That one's wrong because we have function only takes one argument. But we don't know that at the moment when we're evaluating this expression, when we're parsing it, we're not looking at the semantics of fn because it doesn't have to be a function. It could be a lambda expression. N times 3 applied to 3 is okay. Applied to 3, 4 is not okay. All right. And now I'm going to make one more change. I got fn of 3, 4. Let's say instead of increment, we'll make function change to decrement. Okay. And now if I say function of 3, it's okay. Function of 3, 4, it's not okay. I'm trying to figure out when does the function the number of arguments get checked, and I think it must be the evaluation, right? I mean, this kind of proves that, because until it evaluates this, it doesn't know that it has a one argument function. Okay. Well, maybe we're at that moment. Okay, so I think error checking. I think we're going to do evaluate first, and then we'll deal with that. Okay, so if you evaluate a function, excuse me, I guess what you're doing, you're going to take the first thing in your expressions list. Okay, we have a function call. When you evaluate that function call, it's going to parse. Well, no, it's already parsed. It's gonna evaluate its left-hand side, and if it's a function, it's going to pass the function the rest of the arguments. Okay. So let's figure out a test. And I don't know, this is maybe not, maybe we're getting up to evaluate. Yeah, I think we're at the function call evaluate. And let's take another one. We'll just grab well, float value is simple, right? How do we evaluate a float value? Well, you just return it. Okay, that's about as simple as it comes. A variable, to evaluate this, you basically look it up in the symbol table. So evaluate always gets an argument that's the symbol table, and it evaluates the thing in that context. Okay, and so you can see if we've defined function equals lambda n blah blah blah, evaluating function is going to give us a lambda function. It's going to look up the lambda function in the symbol table, or it's going to look up the value of fn and say, oh, here it is. It's this lambda function. This function. I guess we don't care if it's a lambda or not. Here's a function. Use that, and then we evaluate the expression with the context. And I think we're going to evaluate the expression. We're going to have to get the arguments flowing through here somehow. Well, he comes up with a lambda. Then we're going to call the lambda and evaluate it. That's when we get into that closure function, I guess. So this thing's okay as it is. All right, so what's it mean to evaluate a function call? Well, let's go down to function call tests. Okay. And I'm going to borrow one of these other ones just to make sure here. So here's an evaluate. Right. Okay, so function call tests. Okay, so we're going to test evaluate can we give it a function? I mean, do we have a test function we can give it? Well, we'll start here. Okay. It's like, I don't even know. Oh, I'm not even in the right file. Make sure this is the only change I did. Yeah. Square changes, yes. No. Let's put those changes in here. Okay, so what we're going to do, I guess, somehow we're going to create a function call. function call, and if we apply well, it certainly got this. I'm going to give it integer value 42 as its argument. Maybe we got to start with this lambda. And somehow it has to come down to a lambda, right? So lambda expression. The name is n goes to variable n. It's so helpful. Okay. Lambda expression n goes to n evaluated with 42. And we expect the value of that thing to be 42. Okay, xct assert equal expr.evaluate. We'll come back to context. Should be integer value 42. So we need that context, and I'm gonna cheat a little bit and look at these closure function call tests, because I think we're maybe at this point where we're doing the same thing. So lambda expression, it produces, well, it produces a closure symbol table and a lambda expression. Well, I can set this up. I mean, I don't know that we need any real symbol table. I think we're not referencing anything outside of the only reference we have is n, which references n, which is defined in the lambda expression. Okay. How is this test? So we're saying lambda n goes to n, evaluated with 42 as the rest of the arguments. Okay, and it should fail. I'm pretty darn sure it will, since we don't have an evaluate defined. Okay, internal error should not happen. That's coming from its parent. Expression. Cannot happen. Okay, yeah, that's this evaluate. This isn't even really the right. I would almost say this should be like subclass responsibility, borrowing Smalltalk terminology. I'm trying to define an abstract function that must be overridden or should be overridden. Okay. Yeah, I think that's what we have here. Okay, but at any rate, this is what we're getting because we didn't override the function. So let's pull this. Not much help there. Okay. Evaluate the function. Yeah, we need a return. So let's return error expression with error messages dot. We'll use unknown error message for now. Okay, so I want to see if my test is hitting this evaluate. Okay, one failure. Unknown error message. Okay, so we're connected. Right. So I think what we have to do. Well, right now we have lambda expression 42. I think what we need to do is decide if the lambda expression is a function. And I don't know the answer. I'm not sure if that closure is the thing or if it is the function. So let's look in our parser, and we're going to get down to the lambda again. Okay. A lambda basically returns lambda expression, okay, which is just the bare thing. All right, then here, where our closure went, wherever that went, closure function call, okay. Well, to evaluate that might not be the right thing to use there. Evaluating a lambda expression. I mean, somewhere we have to build a closure for it, and I'm not quite clear. I guess I'm hoping this is the right place. So evaluating, well, this is evaluating a closure function call. Inner context. Okay, so the deal here is we take the closures symbol table. Okay, so I don't know, I'm not sure this is exactly a spike or what you'd call this. Somehow we have to get from lambda expression to closure function call. Okay, so if the lambda expression, that's the simple name, lambda name goes to expression. Okay, and I don't think that changes. I think we're right on that. Now, when you evaluate that, we're saying it produces a closure. Okay, and the closure is an expression, right? So it's an expression. Evaluate produces the closure, and then is the type the lambda's type. And what was the lambda's type? Lock this in. Lambda expression. Its type is a function. Okay, I don't think this is going to hold up. Somehow it's got to be the expression type. It's a little complicated. I think this is a little too naive. Okay, when you say lambda n goes to some expression n plus 1, we don't know the type of n at this point. In particular, like it could be anything for starters. Then we see n plus 1 and we go, hey, n plus 1 is either int plus int or float plus float or number plus one of those that turns into one of those. It has a type anyway. So n plus 1 generically, the type is number plus number, I think. And so the generic, it should be constrained. It probably should be required to be number at that point if it's a numeric expression. If it's just n goes to n, then generic is okay. Anything can fit there. So, okay, where are we? So this thing has a function type. That part's okay, and maybe we can live with the other for now. It has a function type. And then the closure locks together the symbol table and the lambda expression. That seems like what a closure should be doing. And yet you can ask the name or the expression, but there's no evaluate. That part is weird. Okay, so if let's go back to function call. If I evaluate, and let's find our tests. Okay. I mean, this is pretty complicated. If I evaluate lambda expression n goes to variable n, and I call that with 42, I should evaluate the left-hand side in the context of the table. I should evaluate the first expression, I guess. Maybe I should say it that way. That thing comes back and it says, I expect an argument. Well, somehow that should be the closure, I guess. The closure says I'm expecting one argument, and I've got a context to evaluate it in. Okay, so let's go back to function call. So I think what we're saying is, well, we know expression sub 0 exists. Okay, so let the function equals expression sub 0. That's the only one we know exists. Okay, I guess if we know it already. Now we want to say function dot evaluate context. Context, but then we need to pass these other arguments to it. I mean, I guess we need to pass expressions.rest. Remove first. I don't want to actually remove. Drop first. Gives me a new slice. Yeah. Okay. Yeah, it's like the functions have It's like a function wants its own evaluate, and maybe I have to know it's a function. If its type is function, it's like, I don't know, I'm used to I guess it's like I want an apply function. I want to say function apply yourself to the expressions. Yeah, I know it doesn't And I almost want it to be this order too, for what it's worth. I want you to apply yourself to the rest of the expressions in this context. And maybe I can get by without the drop first and just let this thing get the whole list. You can know who you are. And I want to return the result of that. And this is not part of it anymore. Okay, this is not defined. Expression has no member apply. I don't think it should be any old expression. I think it should be, well, let's again defer some syntax stuff. As a function, I don't know. It's going to be some new thing, right? No, I'm getting tangled. Okay, I want to evaluate the expression. I think I have to do this. Evaluate with context. All right. Now that thing, evaluate the lambda with the context, that forms that closure expression. So I think this may be a closure at this point. Okay. The closure knows the name and the expression. Right. I don't know. I may be going further than I can reach, but I'm going to assume I'm going to give this thing an apply method. Okay, so let's give it function apply, which takes a list of expressions and it takes a context. And it returns an expression. Okay. I'm going to shortcut it here. I'm going to return integer value minus 99. Okay. Can we get this thing that far? Where's function call? Okay. So we're saying evaluate this thing. You will get back a closure if it's a valid function. That's a place we're going to have to do some error checking. And we then apply closures apply method with our expressions. So this should be an array of expressions. Apply our closure with the array of expressions and the context. And whatever that comes back as, that's the value of this function evaluated there. Okay, let's run this. We're hoping for the minus 99. Closure must be unwrapped. Okay, we will force it. Okay, and I'm going to say to do just because don't want to forget it. Okay, one failure. We're hoping for minus 99. Yes. Okay. We're getting there. All right. This is tricky. I guess because it's like we're defining down at the heart of what does it mean to be a function and what does it mean for a function to be called. And it's kind of funny, but like in Elm, like every function that's got a name is really going to boil down to a lambda expression at some level. And I think we're getting there. So we'll take a break, just a couple minutes again, and come back and see if we can convert that thing to the right expression. All right, we're close. We're making progress. All right, see you in a couple. Hey, welcome back. All right, so we're in the attempt to evaluate things, and we've got the pieces, and we're close. So I'm going to grab one corner, which is the lambda expression. When you do lambda n goes to n, we get the name, the expression, and we store those along with its type. Some function of a value goes to some expression type. It's a little weak, but it's there. All right, we don't care about equals or as string, but when you evaluate this thing, we produce a closure. All right, and a closure is kind of a wrapper that says, grab the values, the symbol table at this point, and it's supposed to be syntactic. Grab the symbol table, and you're going to put your stuff in place of it, if I could say it that way. So in the closure, we've got the symbol table and the lambda expression. Its type is still the type of the lambda expression. That's fine. Okay, and when we evaluate it, well, we don't have an evaluate right now. So we're saying we're not evaluating the expression per se, the closure per se. All right. And so we have this closure that knows the symbol table and the lambda. And when you call the function, it's got the lambda first. It's got to end up as a closure, I think. Okay, at least that's our working hypothesis. You evaluate the expressions. So you got parenthesis lambda n goes to n, value 3, or 42 in our test case. And we're going to evaluate the first one. The lambda n goes to n should give us back a closure. We got that. Now we're saying apply. We're going to basically apply the functions to the expressions. And what we have now, we're just saying, just return 99, negative 99. Okay. But that's not what we want to do. What we want to do, oh boy. And let's find that other, where's that closure thing we had? Closure function evaluator. Closure function call. This is really the kind of thing that's supposed to go on. Okay. So this, I think, is the same as where we are. If you know you have a closure, let's borrow this. Yeah, I think if it's not quite there, it's pretty darn close. So closure. We have the symbol table, we have that. Okay, so the outer context equals symbol table. No, this is the closure. Okay, so this is the closure, so this is already symbol table. The inner context is a symbol table built from the outer context. Okay, and then we add name and the argument. No, I don't know. So what we're trying to do is when you have lambda n, we're trying to get that n shoved into the inner context. And so his name, it's not argument, I don't think, it's expression. But I feel like we're at the wrong level. But at this point, we're trying to say evaluate expression dot evaluate. So take the lambda expression. This one should be our expressions. Well, this assumes that a lambda expression only has one argument, and maybe that's where we'll start now. Okay, so let's take expression sub 1, because 0 is our function, remember? Okay, and I don't know if, I'm surprised it doesn't want an exclamation point or something there, but we're going to say, let's start with a one argument function. If you add the name n, we're going to substitute n for the expression. Okay. Outer context equals symbol table. Should be context. Oh boy. And these things shouldn't be so hard. But the other thing I know I need to do is I got to evaluate this. And I think he's got to evaluate in his context because he's outside, right? Because you're calling a function, you're going to call it on the evaluated arguments. Okay. So we're adding the name to the evaluated argument, and then we're going to evaluate expression, the lambda expression, evaluate that with the inner context. That seems right. And this goes away. Okay. I'm not 100% sure this is the right one, but I think we're trying to get the closures, so the symbols in effect at the closure, add in the argument with the evaluated value. So we're saying the name goes to whatever the right-hand side is, and then evaluate the lambda expression itself. So if it were n plus 1, then name would be n, goes to the value, and then n plus 1 is the expression evaluated with the inner context. So when it sees n, it says, oh, I know, I'll use my value I just did. Okay. The place I'm unclear is symbol table versus context. Seems a little off to me, but I won't argue with that much success. Now, I don't know, there's not much we can do. What's an example we could make? Well, let's run it. Let's see if I'm not sure we'll try it. Okay, so our REPL, we're playing around with trying to get the scrolling right, but we can start now. So if I do 3, I get 3 number. Okay. Now if I do if true, then 3 else 4. Okay. So let's do lambda n goes to if true, then n else 99. Evaluate that with 3. Okay, so we expect 3 back. If we evaluate, it should not happen. Oh, something's wrong. Error. Well, let's just do lambda n goes to if true, then n else 99. Oh, interesting. Yeah, this is this challenge around this n value. Like somehow we're going to have to resolve the types of these things. So right now n is generic. So if true, then n. Generic goes with 99. I think what should happen here, I think n and 99, I think when it takes n and a generic and 99, it should probably turn generic into number based on the if statement. So the common type of a generic and that, but then we need to know that elsewhere. It's like there's got to be a constraint on the lambda n's value. I guess if you plug in, I mean theoretically we could plug in generic to if, and it could come back and say number. Must be a number because it's an integer or potentially a float. Because we could say if true then and else 99.0, or if we passed in lambda, we passed in 3.0, then the type should be float. So if you convert 3.0 and 99, they've got to basically be number. Now this first one, what's happening there? If true, then n, else 3. Well, internal error should not happen is not a very helpful message, is it? Okay. Let's look for internal error. Now maybe, yeah, that's our old friend cannot happen. Callers, oh. Expression. Evaluate. And I think error expression just takes a string. So there's something about our evaluate that isn't happy. Well, I would have said this would be okay. What was our test? Function call test. Lambda n goes to n of 42. Okay, let's try that one. Lambda n goes to n applied to 42. I think that's the equivalent of our test. And we got 42. Oh, I think what's happening here is when you evaluate, you're getting this error. And then maybe we're applying the error to 3. What would happen if you evaluate an expression with an error? Whoops. Oh, that's where I was typing. Okay. If you apply, let's find interpreter, I guess, or error expression. He has no evaluate. I miss abstract functions that really let you do your thing. Well, I guess if you try and evaluate an error expression, you ought to come up with some sort of error expression. Yeah, let's put that test in. That'll be a good goal. Okay, so error expression tests. Do we have a test? No, maybe not. We don't. Okay, so he was just really kind of a dummy class. Yeah, we're suffering from this. Sorry if you're visually going crazy there. I don't know. Started up last week sometime or a couple weeks ago. Rebooting hasn't helped. I don't know if it was my last upgrade of Xcode or something else. But anyway, if you keep typing and ignore the view, you get it. So I think what we want to say, well, we'll make sure this test is alive. Good. Okay. And I'm just going to slide this up. It's up pretty high. I think that's a good thing. Maybe right below the types. Or someday I'll just tell it to start alphabetizing or start doing it myself, I guess. All right. So the test we want evaluating error expression results in error expression. Okay, so let the expression equal error expression. With error messages dot, and I don't think we care exactly what it is. Let's just take this for starters. Okay, and I guess if you evaluate it, does it return itself? Is that what I think we're saying? Okay, so assert equal expression dot evaluate symbol table empty should be itself. Okay, create an error expression. If you evaluate it, you should get the expression you are. That's going to fail with a cannot happen, I think. Succeeded and didn't get a little thing, right? What the heck? How about if I run the class? There you go. Okay. Internal error should not happen is not equal to that. Yeah. So we got to get to error expression. And we're going to override. You're going to tell me? Yeah. Evaluate. We'll just return self. Okay, so if we run it, whoops, run it. So we had lambda n goes to if true, then n else 4. Evaluate that, should get an error. Yeah, that's sort of true. All right, and now if we put it in parentheses and evaluate it, applied to 3, should get 3, well, should get an error. Then an else clauses must have compatible types. That's not bad. Okay. Yeah, so a little more error handling. Let's put that in our to-do. Okay, so the story there is evaluating an error expression yields itself. Okay, I think we did that. Okay. Evaluate a function. Well, we still don't quite do this. And I think we're focused on one argument functions for now. Okay. All right. I just kind of have to clear it. Well, what do we got? Well, we've seen there's this other error. The type is not quite right. So we have to say what happens when you define a lambda, what's the type of the right-hand expression? Well, it's a function. Well, no, it's the type of the right-hand expression has to take into account how do I want to say this? So if you had, let's say you had if true, then n, else n. Okay. I don't know what'll happen. All right, let's try it. Lambda n goes to if true, then n, else n. Now those two are generic. They're both generic. I think, I don't know. 3 of generic. Now that's probably not right. Let's go. Oh, I can't cut and paste across. We'll do the same thing in the REPL. So we said lambda n. If true, then n, else n, applied to 3. We expect a number. Okay, or integer. Either one I would have been okay with. So the type, but if I just say this, I expect it to be any goes to any. A goes to A, yeah. Okay. We're still learning. This right, but if it was else 99, it's going to be number. Right. So something's going on with our types in the if statements. I don't know. Okay. Well, I think if you say if you pass in some sort of generic, and I don't know if these have to extend at some point, but when it says number goes to number, it's got to be the same kind of number. If it didn't, it would say number goes to number one. And we haven't dealt with that kind of thing at all yet. Generic stuff that far advanced. We're still struggling on A goes to A. So an if statement, the type of the if statement, this n else n thing, it looks at it and it says, what's your type? And he answers generic. And are you compatible with your other type, generic? Yes. So we have a lambda as a function that takes any value, and whatever type that is, it matches the type. Okay. The actual evaluation, we don't want to lose the type. And so I'm not sure how we're doing that one, but, okay. So I think what's going on is our if statement needs to handle generic types. And if the left-hand side and the right-hand side are equal, we do something, we're sort of okay, right? I think we decided that. If the left-hand side, I haven't really done that one, have I? Lambda, m, okay, goes to if true, then m, else m. We think that's going to be generic goes to generic. Yeah. Okay. The whole thing is a closure. Yeah, that's interesting. But the closure, we really just want to see the type. What do we do here? Oh, it just says function goes to. Okay, so if it just printed out function goes to. Does it have no value? Or the value is the word function? I'm not sure. Okay. So I think our if statement needs to be, I think it needs to say if, well, it says if the types match, then just return them. That's okay. If the type on one side is float, what does it do? Oh, well, we have this one. It says it returns a number. So let's do the same one with 99.0 float. Okay, so if a float plus a generic returns a float, a number plus a generic returns a number, a string plus a generic returns a string if it's constrained to be the same type. Okay, and then I forget what this function even means, but I know it's, oh no, it's 2. No. Let's find an Elm integer function. Elm integer function. To end. I had something here. Okay, I've got the Elm cheat sheet we looked at the other day, trying to find something that looks like it's got to force an int. Integer division, 2 right slashes. That's the one. 3/2 1. Okay, returns an int. So if lambda n, if true, then n, else 3 divided by 2. I think it's going to be int. Yeah. Okay, so if one of the types is generic for the if statement, I think it should say use the other type. If they're both generic, that's fine. They use the same one. Okay. Let's add that. So this is really a story about ifs. If statement handles generic types. Let's say it that way. Okay, and maybe I can write a test in the next minute and a half. Okay, so the type comes from the saved type. So float plus int is float. Integer number. Okay. Yeah, so let's see. Test. Well, where's that type getting computed? Let's go in if expression. Is that a parsing thing or is it a, I think it might be in the parser. Right, its custom type is Boolean, return value true. QS string. Okay, the evaluate is the type, which is the one we were created with a type. Okay, so it's not a parsing issue or an evaluation issue. It's handled up at parse time. Parser. I guess this should be if statement type int plus float returns type. If statement. Okay, so test if statement. If statement type. Float plus generic returns float. And then I also want generic plus generic returns generic. And it's not really float that matters. Non-generic plus generic returns non-generic. I think that's the way we can say it. All right, well, that's a start. I'm going to say XCT fail. Pick up here. All right, so we return tomorrow morning, 9 to 11:30 Eastern time, and we will get this if statement handling right. And there's still something not quite right in the evaluation, I think, but we'll see what happens. So we'll move on. We're closing in on this thing, I think. It really is the heart of the problem for an Elm interpreter to be able to evaluate functions. It's pretty critical. So thanks for joining me, and I will see you in the future. Bye.